Okay, this is a help video for part C and D. We've got a new formula that counts bacteria within a lion. When we get too many bacteria, the lion gets ill. So we've got our N value, which counts the number of bacteria, and we've got this formula here, which is the formula that models the number of bacteria. It changes as T changes, and T is now days, not years. So the first thing it asks us to do is to find the initial number. Now the initial number of bacteria is the number of bacteria when counting first began. Counting first began means how many days have gone by. Take that value, put it into the formula and show your calculation. It's very similar to what we had to do in part A and B. The next bit says that the animals are in danger if the number of bacteria exceeds 48,000. So it asks us to use a CAS calculator to find a time for that number of bacteria to reach 48,000. So the number of bacteria is described by N. 48,000 is going to replace N, and we're going to have to find out the amount of time. So on our CAS calculator, if I wanted to figure out how many days for 1,000,000 bacteria, I'd replace N with 1,000,000. I type in the rest of the formula and solve it for T. Likewise, if I wanted to figure out how long for 55,000 bacteria, I'd replace N with 55,000. So 55,000 is a bit closer to 48. You can see the number's going to be in the ballpark of about 17 or a bit less than 17. Alright, let's have a look at what you have to do next. You have to draw up a table of values to show your results. So your table of values would need to have T values and N values. We just found out that it's around about 17 or so. Okay, we might go up to 20. You don't have to put every single day from 0 up to 20, but maybe count in fives at least. I reckon if you've got 6 values, you'll be able to plot it pretty accurately. And once you've figured that out, however many there are in each one of these, and so on, then you can plot those values in a graph, which is what you have to do in question 12. It asks you to talk about whether it's growth or decay. We can already see it's going up, can't we? So it must be, well, you can still answer it. Let's have a look at part D. Now we're giving the animals a drug. In other words, now that the number has grown until it gets to 48,000, we're going to give it a drug and try and cure it. So if we have a look at the graph of that, missed an axis there. So we've got our number of bacteria being counted along here, and the number of bacteria grew until it got to 48,000. So this is part C. This is the graph that you've done in question 12. And over here is our mystery number. It's about 17 or somewhere in that kind of ballpark. Now we're going to do part D. And this is where we're curing it. So presumably we're getting some kind of graph where the numbers are dropping. And what we're trying to figure out is how many days go by until they're cured. And the definition of cured is that there are 1,000 or less bacteria. So part A, the bacteria increased to 48,000. Part D, they start at 48,000 and go down until they get below 1,000. Use CAS to find the number of days it takes the animals to be cured. So that's again using your solve function. We're going to have, of course, our part D function in here instead of part C's function. And we're going to be asking when is it cured. So what value do we need for the number of bacteria for it to be called cured? They're the two values you're going to need to put into your CAS calculator. Draw up the table of values. So again, we are going to have T and we're going to have D and we're going to put in 0, 1, 2, 3, etc. And we're going to put them into the table. The only thing a bit weird about this one is because we're tacking it on to here, day 1 in part D is going to be here. So if that was, say, 17, it's the 18th day after all of this began. So we're just going to have to add this value onto 1. And then after T equals 2 for part D, again, it's 2 past there because we're tacking these values onto the end of part C's graph. Okay, so hopefully that is enough for you guys to get that sorted.